Thank you, Niski. So, good morning, everyone. It's nice to be here again and tell you my progress in my PhD. Well, unlike my colleagues, I didn't try to answer these nice questions about ecology, dendrochronology, genetics. I'm an engineer and I try to focus in generate tools and data for forest management. So, today, I'm talking about crown morphology models for Aleppo pine using LiDAR data with terrestrial laser scanning and drone LiDAR. So, in our forest, especially in fire-prone ecosystem, crown morphology plays a key role because it determines the canopy fuel structure, commonly explained with variables such as crown height and crown density, and canopy bulk density also. However, crown structure is still poorly represented in many forest models because of the limitation in traditional field measurement. The Spanish National Forest Inventory is a great dataset. They include basic descriptors of the crown, but not for all the trees. So, for a species without a available crown profile model, these fuel parameters are derived under the assumption that the crowns have relatively simple forms, like cylinders or cones, and assume that the biomass from leaves and a small branch is homogeneously distributed. Then the fire simulators predict unrealistic scenarios. So the main object is to develop a novel model to capture detailed tree crown data, then develop crown morphology model from Pinus halepensis, and in the future, I hope I can compute canopy full profiles to estimate realistically canopy base height, canopy full load, canopy bulk density, and the canopy height. So our study area is in these 5 zones, in Palencia, Navarra, Zaragoza, in Guadalajara, in Navarra. We measure around 10 or 12 plots with 17 meters radius. And in every plot, we measure classical variables from a traditional forest inventory. Then we use the terrestrial laser scanner between M5 and NAN scan positions. If we have, if the plot is very dense, we also put an extra scans, but at least we have 5 positions from the terrestrial laser scanner. Then we fly the drone and take the data. So this is the workflow. We have the drone LiDAR, the terrestrial. This works. This thing, okay. The terrestrial laser scanning, the drone LiDAR. Then we need to co-register these point clouds, have a big dense point cloud, and then we need to do the tree segmentations. We do this in 2 steps. First, with a deep learning algorithm called TreeLearn, but doesn't work perfectly. So in the second time, we need to do a manually refinement of the crown. So we spent like, I don't know, 6 or 7 months in this step in the tree segmentation. Then, when we have this data set, we compute tree level variables and plot level variables. When we have all this data, we can try to find a good statistical modeling to do this, to characterize it, to make the crown morphology model. In this time, I test linear mixed models. Then we have these explanatory variables. We had use also an algorithm to detect the DBH, the diameter at base height, and then the basal area of the tree, the height of the tree. Then we calculate also the trees per hectare, the basal area of the plot, the basal area of the larger tree, and the canopy cover. Then our response variables have the height of the first branch, a difference. In other words, we manually detect what is the first branch and take this data. Then we calculate the maximum crown width and the height of the maximum crown width. We take the equivalent streak with the same area. For this is a maximum crown width, and then we calculate the equivalent of the circle with the same area. Then we also have all these slices from the tree between 30 centimeters. And then with this we can compute also the crown volume for every tree, just the sum of the volume of every section. Then with our first result is an amount count of data. So we need to manage this. We have 2 terabytes, 2 NASes really full of LIDAR data. So well, we have a studio to solve this problem. Then also we have at the second time high resolution 3D point clouds generated. And then we measure 54 plots, but we can process at this time 35 plots and have more than 900 individual trees. This is a summary of the variables, and with these variables we try to modelize the crown morphology. So with the log linear mixed effect models, including random effects to account for hierarchical structure with the zone or the plot, we can see here for every model the variables that play a key role. And then here from the mixed models with the random effects can catch the variability, but with here at the face branch we have not a good fit, because if we have not random effects, we cannot explain very well the comportability of the height of the first branch. But for preliminary models, I think this is good. Then we have also these typical residuals from the models. Also, we can see here at the height of the first branch something strange here. So I need to test more models to have a better management. So in conclusions, TLS and drone LiDAR integration provides a detailed canopy insight. We have promising crown morphology models for Pinus halepensis. And in the future research is to model refinement, test nonlinear models to increase accuracy and predictive power. Then we also develop a complete crown profile. It's a different morphological crown morphology models. We have also 4 points to capture the shape of the crown. And in the future, we have data to complete a continuous profile model. Then the objective is to integrate with other tools, connecting the crown profile models with fire and forest growth simulators. So thank you very much. Thank you very much.